We'll see what happens. I wish him the best of luck. I did one year. I didn't have him, but he was in ACP calculus, so I didn't know him. But he took the AP Calc test. He got a 1 that year. So no, he was an ACP. Oh, the AB test. Yeah. He had asked me for some. He had asked me for some materials and stuff, and so I gave him some stuff. I don't know if he ever looked at it, but anyway, who knows? That was like 4 years ago. All right, so your question was on the last one. What number was that?
It was 15. I can tell you the problem right now if you want.
Sure.
It's integrate 2x cubed minus 4x squared minus 15x plus 5 on top. And then that is over x squared minus 2x minus 8.
And this wasn't fun for you?
I just didn't know where. So I think I'm missing one part of it. I'm trying to look at this solution to it. I don't know where they got the x squared from, the end product, because I got the final answer is x squared plus 3 second ln x minus 4 minus 1/2 ln x plus 2. I got those last two parts. I just didn't get the x squared, and I was trying to look at where it came from.
My first thought is I should start with long division. Did anybody do partial fraction and it worked completely? Okay, so a lot of times when the degree on top is bigger than the degree on bottom, I might go through like long division to see what this equals. But since the bottom factors, we'll just see what happens. So do you think you just made a mistake somewhere?
Possibly. But I did all the partial fractions and got the natural log and all the A, B, that are on top of the factors. I just didn't get x squared. I don't know where it came from.
Anybody know what he's talking about?
Yeah.
So let me see then, if everyone had the same issue.
Really?
Yeah.
I just don't know where that x squared came from. So as long as that goes there, and then it goes to 2x plus x plus 5.
That from just integrating 2x.
Yeah, but I don't know what the 2x number is. Like, I don't even know what it is.
Oh, yeah, so that's what I was gonna say.
Because I knew it'd be x squared if you integrated it. But
Yeah.
I just don't know where the 2x came from.
Okay, so my advice is this. If you guys have a fraction, if you're integrating a fraction, I mentioned this, how there are so many integration techniques. When in AB, we only learn U substitution. I mean, that's basically it. It mentions in the syllabus that they have to do long division. I've never seen it show up. I assigned this one in here. So what I always advise them, I wasn't 100% sure though if this was factorable, if this still works, but I think it does. So here's my advice. If you guys have a fraction and the degrees are the same, or the upper degree is bigger, I would go through and divide these two, this fraction using long division. You guys remember doing long division? That's probably why I assigned this one when I ended up picking it. So I want to see what this fraction is equivalent to. This is an integration strategy that, again, it is part of the curriculum. I've never seen it show up on an AP question, so I don't talk about it a lot, but it's probably why I ended up assigning it. So I'm going to go through and do long division. So just to refresh your memory is when you do long division, you do first term divided by first term. When you do the division part, you only focus on the first terms. So 2x cubed divided by x squared is 2x. So that's where that 2x is going to come from. Then multiply the 2x through. So 2x cubed minus 4x squared minus 8x. And then I subtract straight down. In Algebra 2, when I teach, yeah. That's why I spelled your name wrong. Yeah, it is. I screwed up. In Algebra 2, when I teach this, I say instead of subtracting, I would flip all the signs and then add. It just makes a whole lot easier. So I would flip it to negative, positive, positive, and then add straight downwards. That's going to be x plus 5. Then as soon as this degree is less than this leading degree right here, then you're done. Like that's your remainder. If this had said x squared right here, we could divide one more time. But since it's x to the first, we can't divide x to the first by x squared. So the way we write this, we would say 2x, and then we do plus, and we put our remainder over our divisor, which is where that came from. And then go through and do your decomposition. So again, in general, 'cause it's always like, yeah, you can know how to do all the techniques, but if you don't know how to go into it and know which one to use, then you're screwed. So my advice is anytime these degrees right here are the same or the top is bigger, I would divide it out. I can't foresee that happening a ton, if at all, especially on the BC test. When they're trying to assess a lot of different levels of integration, this might not be one that they throw in there, but it is in the curriculum, so.
So you just leave the 2x alone when you go through decomposition.
Yeah, so now you're just trying to decompose this fraction right here. Anything else? Nothing else? You guys really like your other seats better? Like, do you wish you were in your other seats?
A little bit. Yeah. Just used to it.
You guys want to move?
I mean, yeah. What do you guys think?
Who wants to move versus indifference? Raise your hand if you want to move. 1, 2, 3, 4, 5.
Indifferent.
Who's indifferent? All right, go ahead and move. Sorry at home for wasting your time. Maybe you'll like your new seats better.
We really got
New year, new seats, tried to switch it up. And this is the thanks I get,
So many years.
I'm coming home.
Now you're going to sit down. It's going to feel weird.
I don't think so.
Dude, it's like I was here last semester.
It's been about over 5 weeks since we've seen each other.
Yeah.
I think like 5.5 weeks. I didn't see you during finals. We had 2-week break. Yeah, since before finals. You guys at home, I haven't seen even for longer because the AC group. Man. I was excited to get back here and teach. Oh, Vince, I got that calculator fixed. Did you hear me and Mr. Ferris talking about it? I ended up calling. So the downside of recording the Zoom, if Braden's going to be doing it, he's going to hear just a lot of rambling. So it's going to be wasting his time. But if he chooses to do it, so he won't learn like everything he needs until I told him end of February before he should start watching the BC stuff. So he won't be watching these until March. But anyway, so I had this calculator. I always update. Did I do it to anyone in here? Did I give anyone in here my operating system? So sometimes the notation on the 84 plus is not like they call it pretty print, like the nice math notation when you do like math 8 or math 9, how you just like input the things. Works with logs too. But I tried to put my operating system on a kid's calculator yesterday in Algebra 2, and it's always worked. I've done it to 100 calculators. Well, his like broke. It said error. It said turn it off and turn back on. So I did. And then it said waiting for a new operating system. And it would not go between do anything besides those two messages. So the calculator wouldn't work. I looked up online, a lot of options. I couldn't find any. It was about 3 hours of my life yesterday trying to fix this kid's calculator. So I called Texas Instrument. If you ever want to talk to Texas Instrument, good people. It was 1-800-TI-CARES. That's the phone number. But I talked to this nice lady during AL for an hour yesterday, and we ended up fixing it. She sent me the new operating system that I had to download to my computer. I had to plug the calculator to my computer and download software from there. It was a headache, but it's fixed. So I felt good.
That was going to be the solution.
Yeah. Well, we tried that in Mr. Ferris's class, but I think we selected the wrong software is what happened. We tried to do it that way. But anyway, he's a smart guy. You guys like the smartest person I've ever met, Mr. Ferris. So you've never had the pleasure. Good dude. All right. So today we are learning what is called integration by parts. And in all honesty, these first 3 lessons could be rolled out interchangeably. Like there's no there's different things. Like arc length is just a different application for integration. Integration by parts and partial fraction decomposition, again, just 2 different integrating techniques. There's no rhyme or reason why they are listed how they are. But integration by parts is, like I said, it's the product rule for integration. And it comes from the actual product rule for differentiation. What we are now, after today, going to be able to do, we are going to be able to integrate functions that are products of 2 functions, which we haven't been able to do before. We don't learn this in AB. If a product comes up, we can't do it. But now we are. Okay, so this is called integration by parts. All of this stuff, I'm not going to get into. This is just kind of the behind the scenes where it's coming from. But if you notice, you're really just doing the product rule right here. Right at the beginning, it's taking the derivative of a product and it's doing the product rule. First times derivative of the second plus second derivative of the first. And then it's just changing notation. And then it's just saying, okay, let's do all this stuff. But that's really, you don't need to worry about all that. What you need to know is this box right here. This is the formula you guys need to know for integration by parts. So when you are integrating a product, so the product they have here, U is the first function, dv is the second function. So when you're integrating u dv, so 2 things being multiplied, here's your formula. You take u times v, which I'll talk about how we find these things, but this is just your formula. You take uv minus the integral of v du. My first year teaching this class, they came up with a mnemonic device to help remember this formula. They called it ultraviolet voodoo. That's how they remembered the formula. They said ultraviolet voodoo. All you need to really remember is the minus sign. You're subtracting. So I thought that was a pretty nifty mnemonic device, ultraviolet voodoo. So u times v minus the integral of v du. What we're going to have to decide is what is u and what is dv. Like we're going to have to make a decision in our, if you look at our problems, what's u and what's dv. Down here, what's u and what's dv? Those are the 2 things we have to choose what to be. I remember in calculus, my senior year, or with this, did I learn this my senior year? Or would this have been in Calc 2? I really don't remember. But anyway, I remember always struggling and I would always pick like the wrong thing. And then I had to like redo the problem. Well, I went through a BC conference before I taught this class in the summer, and I learned, I was always taught this thing right here where it says guidelines, and it says try letting dv be the most complicated portion of the integran. I actually scrapped this part right now. I've learned a different way to do it. Instead of picking what dv is, we're going to focus on how do we choose what u is. And there's kind of a checklist that you go down the line and like what u should be. So here is how you're going to choose u. Spelled choose wrong. See, I'm just a bad speller. So here's how we're going to choose u. This is the order. I forget the word. What word am I thinking of? Not scaffolding. Like if it's not this, then you do this one. If it's not that, then you use that one. What's that word? Huh? A flow chart? Oh yeah, a flow chart. Yeah. So here's our things. The first thing we're going to look for is there any log function in the integral? Is there a log function? If there is, that's what u is going to be. We're going to have u be the log function. Okay. The next thing is we look for, which we hope doesn't show up, but we look for inverse trig. I've never seen this happen, thankfully. The next thing we look for is an algebraic component, like a polynomial. So if there's we're not done, but if there's a log function, that's u. If there's not, okay, now is there an inverse trig function? No? Okay, is there an algebraic function? So this is how we go down the line. There's 2 more. Then there's trig. So that's your sine, cosine, tangent. Then the last one is exponential, like e to the x or something like that. So that's our checklist. The acronym I learned for this in that BC thing I went to, they called it LEAT. They called it LEAT. Well, the first year I taught this class, they didn't like that. They didn't like LEAT. So I had a girl, and it still has stuck with me. She goes, I like culiate. She goes, the ku is the C and the U, like culiate. I thought, oh, well, that was catchy for me, and it still stuck with me. So culiate, if that's going to help you choose you. However you guys need to think about this, it really doesn't matter. But culiate for choosing you. So you guys have ultraviolet voodoo, and you have culiate today. Those are the two things you have to remember. Aside from that, it's just, okay, now how do we do it? And it's not bad at all. So let's do it. Let's evaluate the integral of x times e to the x dx. So if we're trying to integrate a product, the first thing I would look for is u substitution. Don't forget about that, because like if I gave you an integral and it was x and then e to the x squared, for instance, like if I gave you this right here, this is u substitution. You don't do integration by parts. You would have u be x squared. The derivative of that is 2x, and that shows up here for your replacement. So you need to be on the lookout for just different things. I would always start, if I'm integrating, I would always start, does u substitution work? That would be kind of my flow chart thing. I would start with u substitution. If that doesn't work, then I'm like, do I need to long divide? Integration by parts. Next class, we integrate out to infinity. Or we try to integrate across a vertical asymptote. They're called improper integrals. I think that's our last integration technique is next time. But anyway, so this, we can't use u substitution, so we have to do integration by parts. That means I need to choose u. So I go down my checklist. Okay, is there a log function? No. Is there an inverse trig? No. Is there algebraic? Yes. When I say algebraic, again, that's polynomial. That's 2x squared, x to the third, whatever that is. I have x right here. So u is going to be x. So here's how I write this out. So u is going to be x in my formula. dv is the rest of the stuff. So once you choose what u is, dv is the rest, including the dx portion. Now here's how I write this. You guys can do this your own way. I'll show you why I write it this way. So I define u, and now dv is the rest. So dv is e to the x dx. So in the formula, you'll notice there's a u and a v and a v and a du. And I don't have pretty much any of that stuff right here, except for u. I know what u is. So what we do is this. To find du, we differentiate the left side to figure out what du is, and we integrate the right side. So when I differentiate the left side, this is going to be du equals, and then this is going to be 1 dx. It's kind of like the u substitution right there. On the right side, we go up, we're going to integrate. So when I integrate dv, that gets me back to v. And when I integrate e to the x, I get e to the x. Once you have these four things, like the hard part's done. Now it's just plugging it into ultraviolet voodoo and going from there. Because we have all four components here. So that means our integral of x e to the x is going to be the same as uv minus the integral of v du. So u is going to be x. V is e to the x. So that's the uv part. Minus the integral of v, so e to the x, du, which is dx. And then there's just one more part. Now we just have to do that integral part. So this is going to be x e to the x minus e to the x. And then we can't forget plus c. What do you guys think of integration by parts? Solid. All right. The next one. natural log of x. So there is no rule for integrating the natural log of x that you guys have to know. But we are able to use integration by parts on this problem right here. We need to start by choosing u. First thing I look for, is there a log function? Is there? Yes. So u equals natural log of x. So if u is the natural log of x, then dv is the rest of the stuff. What's the rest of the stuff? Just dx. It's like 1 dx, but it's just dx. So dv is dx. I differentiate the left side, I integrate the right side. So du is 1 over x dx. Hopefully you remembered, I spoiled it, but the derivative of natural log of x is 1 over x. Integrate the right side. So v equals x. And then away we go. Just integrate the crap out of this. I had a kid, I mentioned the integration bee at certain schools. I had a kid who, he came back after winter break a few years ago and he said he won the Wabash integration bee. I was like, that's pretty cool. All right. So it's ultraviolet voodoo. So natural log of x times x. I would put the x in front. There's your ultraviolet. Minus the integral of v du. So now v du is going to be x times 1 over x dx. X times 1 over x dx, which is really just dx. And then we finish. So x natural log of x minus, and again, we're really just integrating 1 with respect to x. So it becomes x plus c can't see it. You can't see it. Okay. All right, you guys try the next one. Have fun. I triple dog dare you.
And then, just to clarify,
Yeah.
that like acronym thing, that's like the order that you choose in, like if there's a log, that's the very first thing. Okay.
If there's a log, that's the one that you use.
Okay.
I mapped out our entire semester.
What's it looking like?
We should finish our last lesson March 23rd.
Wow. What is that though? Isn't that like one of the first couple?
What test?
Oh, the AP.
AP test is May 4th.
Oh, okay.
Yep. So I think I have our last lesson, it's the cycle before the last day before break. We'll do something fun that day. You don't want to do anything new or learn. Bring in donuts or something.
What,
I think that would be March 25th.
Before spring break.
Yeah. Our last lesson, we have a test coupled with the last lesson, the 19th and the 23rd. The 25th is the last day for you guys before break. It's a Thursday. Yeah, we'll see. I'm not worried about timing. I think I got it all pretty much figured out. All right. Here's what you should have had. You guys at home can see that. I don't know what you guys can see. Yes. There it is. So yeah, when you go through the Culiate for choosing U, like the very first thing, if that's there, that's what you need U to be. And then inverse trig, like I said, the hope is that is not there. I've never seen it. I don't know the inverse trig derivative rules, by the way. Do you? What if it shows up on the AP test?
Well, I'm gonna look over before they. I'll probably look over before the test.
What's the derivative of arc sine of U?
1 plus u over the square root of 1 minus u. I don't know.
No.
U prime. Something.
Yeah?
U prime and sin squared u.
No.
It's u prime over the square root of 1 minus u, right?
Oh, so close.
U squared.
1 minus U squared.
Yeah.
Good for you guys. I would have had no idea.
I looked
Team
at
effort.
them maybe for a good 3 minutes before the final.
I think I learned them last year, briefly. for
Yeah.
one of the tests.
Yeah, she has an unfair advantage.
Not this semester.
Now she's in unknown territory.
Level playing field. All right. Any questions on this one? All right. Next. Shouldn't have spoiled it with putting that there. Oh my gosh. They said February 1st, they should like officially be done with the roof.
Oh my God, it's a month, so
What's today?
the 8th. Oh, okay, 3 weeks.
Yeah.
back.
It is. All right.
3 whole weeks of construction.
So we're going to go ahead and we're going to integrate this one. Forget it even says repeated integration by parts and tabular method. Let's just pretend like we're going to do integration by parts. So I go through Culiate. Is there a log? No. Inverse trig? No. Algebraic? Yes. So I'm going to have u be x squared. U is x squared. And so that means dv is the rest. So dv is sine x dx. Differentiate the left side, integrate the right side. So du is 2x dx. Going backwards, v, well, we're integrating sine, so be careful here. Just watch out for your signs. When you integrate sine, you get negative cosine. And then we apply our little formula, ultraviolet voodoo. You guys like it, don't you?
It's gonna stick.
Exactly. That's the point. So uv minus, there's a reason I'm writing so small, minus the integral of v du. I'm just going to make, since v is negative cosine, I'm just going to pull the negative out and make it plus. And then du is, oh shoot, 2x dx. I would like the 2x to be in front. Why did I write in pen? Mr. Giordano. Whatever. Now we have to integrate 2x cosine x. So what do we have to do to integrate 2x cosine x? We gotta do it again.
Oh,
Hence, repeated integration by parts. Sometimes you gotta do it a couple of times. I am gonna show you what's called the tabular method here in a second, okay? That makes it a little bit easier, but let's do this for now. So I need to integrate this integral now by integration by parts again, okay? So I go through my checklist. Any logs? No. Inverse trig? No. Algebraic? Yes. So I start over. U is 2x dv cosine x dx. Woo! Now we're starting to roll, boys.
We're starting to roll.
All right, so again, we have ultraviolet voodoo. So 2x sine x. I would probably bring down the negative x squared cosine so you don't forget it. That's something I would do. I would forget it. Ultraviolet, so 2x sine x, and then minus the integral of v du. So 2 sine x. Whew. Getting a little hairy. But we can integrate 2 sine of x pretty quickly. If it is, I get nothing. So it's going to be plus 2 cosine x plus c. Oh, baby. So here's what I want to show you guys, kind of a little shortcut for doing this. And it looks a little messy at first, but then you'll see how valuable it is to know this when we get to example 5. Basically, if you have an algebraic component and trig or exponential, like e to the x or something like that, you're trying to demolish that x squared. Or in this next one, in fact, you know how many times you would have to do this? Instead of repeating it, you'd have to do it another time. You're not going to want to do that. Maybe one time is fine. Like for what I'm about to show you, it's not necessary to know. Okay. And if you're taking your test or something, or you're doing your assignment and you forget about it and you do it this way, I mean, it's not the end of the world to do it multiple times. But again, what I'm going to show you is just kind of a nice, I don't know, they call it the tabular method. Little shortcut. So this is the tabular method I'm about to show you. You do need an algebraic component to use this. This doesn't just work on like all the problems. Okay. Typically I would do it if you have an algebraic component and the other component is trig or exponential. That's when I would do it. Okay. I wouldn't do it when there's a log piece. Like I would not have done what I'm about to show you on example 3 right here with that natural log. So the other component would be trig or it'd be exponential. Okay, so here's how it's going to work. I'm going to set up my u dv. And so my u is my algebraic component. So in this case, x squared. My dv is the other component, so sine x. For this method, we don't have to put the dx there. And then here's what we are going to do. We are going to differentiate all the way down the u column until we get it to 0, until we blasted it away. So we're going to do the derivative on the left side. So we would have 2x, we would have 2, we would have 0. We're trying to reduce it to nothing. So we differentiate the left side. We integrate all the way down on the right side. So on the right side, we're going to integrate straight down. Here's where you need to be careful. This is like the only downside of this method is a lot of students, your brain will want to differentiate. So we're going to integrate. So the integral of sine is negative cosine. The integral of that is going to be negative sine. The integral of that is cosine. So that's the setup. And then what we're going to be doing is connecting. It's really wacky. This method is really wacky. We're going to be connecting diagonally here. We're going to be multiplying these pieces together to get our final answer. There is one more little wrinkle. As we go down the line, we always start with a plus. We need to alternate signs with our multiplication here. Plus, minus, plus. There's a lot of students that don't like this. And like I said, for this particular example, maybe it's not when you do it because it really didn't take that long. But if you're seeing x cubed or you're seeing x to the fourth, it's a big time saver. So all I'm going to do is just multiply these diagonally, and that's my answer. So if I multiply x squared, this doesn't mean it becomes positive. It just means like you're multiplying by a positive 1, if you will. So this would become negative x squared cosine x, which you could see that that was our first term over here. And then we have positive 2x sine x. And then we have positive 2 cosine x plus c. You're throwing your u's in there, differentiating the 0, integrating the other side. Yeah.
It always starts positive, right?
Yes. Always a plus sign to start with. You guys ever seen Stand and Deliver? Jaime Escalante, the what? No? Okay. Okay. All right. I thought it was like a math movie that like you guys have always seen before you got to me.
What's it called?
Stand and Deliver. It's based on a true story. This guy teaches, it's really, I have it. I mean, we'll watch after the AP test. Honestly, after the AP test, we're gonna have a month with like nothing to do.
Good.
After we.
So
Sounds fine to me.
a
I think DC deserves it.
couple years ago, we just played like euchre and card games for like a straight 2
I do
weeks.
that.
But anyway, it's a movie about this guy who teaches at, it's a true story. He teaches at this inner city school in California. And he takes over this Algebra 1 class. These kids can't solve or do anything. And he ends up like staying with them until they get to calculus. And they take the AP Calc test and they get accused of cheating because of like how well they did.
Oh, I saw it in eighth grade. No,
Yeah.
seventh grade.
That's what I'm saying.
Yeah.
Seen the South Park adaptation.
Oh, I'm sure it's funny. South Park is a very clever show. I mean, it's raunchy and crude, but like deep down, they're very smart. Anyway, try the next one. Maybe we'll watch that.
What, the South Park version?
No. But there is a scene in Stand and Deliver. You don't really exactly see what he's doing, but he like goes to the chalkboard and he goes tick, tack, toe. And it's basically this that he's doing in the movie. Doesn't matter. Okay, do example 5. So you have either way. You can do integration by parts multiple times or tic-tac-toe. I don't know why he says tic-tac-toe. Is anybody doing the integration by parts? Repeated? I'm just curious how long it would take. Anybody at home doing the repeated integration by parts? Okay. Yeah, Steven?
Yeah, I didn't. Got confused. I put like the x cubed I differentiated as 2x squared instead of 3x squared.
Hmm.
So that's,
That made
So
everything
I-
off by a factor of 2 or something.
yeah,
For you.
I got all the integration right, but
This is about as tough as integration by parts will get that you guys will have to do. You won't come across something like this either. I was just trying to show you guys because I don't think they'll ever make you have to do one by the tabular method. They're for sure not going to make you do an integration by parts repeated like multiple times. So it's just a tool to have in your back pocket. I could see this happening possibly. Jeez.
A little hard to read.
Okay, can you stop and just?
But at home, they're not bothered at home by it.
Oh,
They don't see it, the screen bouncing.
What are they laughing about?
They can't hear
I
you.
bet the at-home group feels so left out when we're here. I
Well,
feel
do
like
you?
we're more to talk to the class.
Do you feel left out when you're at home?
No, because you guys just go straight into the lesson.
Oh.
There's no-
All right, last one. Here's an AP style question.
Really?
What?
Like, I'm missing out on the side.
No.
Interesting.
It is interesting. They always have creative ways. I like to use the word creative. They have creative ways of asking questions on topics. And again, I've mentioned that's the difference between college calculus and AP calculus. Like college, you just have to go through and do the process. AP, they're like, how can we just crush them?
They call it Lord.
I did this a certain way. I remember last year they told me how they did it like very quickly and easily. A couple of them. Anyway. I don't remember what they said. Give me. No.
I was like, what in the world? Yeah. I was like, oh, well, I did something real wrong with that answer.
You should narrow this down to C, D, or E right off the bat.
Yeah.
I would probably get rid of C.
It's a theory guy. What do you finalize this thing?
I haven't even started yet.
What?
I was spaced out for a minute.
So yeah, that's all I've got. Got another formula for this one,
Yeah.
because you gotta see how the sign changes.
Did you get E?
Oh, wait, hold on, now that I just said that,
No, because it was.
it's, I put D.
Yeah.
I got E.
Is it, it's because of the negative f of x.
All right. So here's.
Oh, because you subtracted, oh.
Oh, okay, yeah, yeah, I
Yep,
see,
yep.
that's what I need to know.
It's because it turned into a plus sign before
Well,
the
because I
integral.
was like,
Yes.
oh, if it's a plus sign, it has to be double negative.
Yeah, that's what I put D.
Yeah. So I mean, here was my thought process. I don't know if this is the most ideal way of going about it. First thing I tried to look at was based off of what this looks like, which of this was U and which was DB. And so I noticed, okay, if that's sine, it became negative cosine. That means that they had to have integrated sine, which means that had to be the DB part.
Which is why I went to plus the integral of 4x cubed.
Yes.
Sign of that.
Yeah.
Okay.
So that gave me U to be f of x. So I went through kind of the ultraviolet voodoo part here. And then, yeah, that is going to flip to your plus sign. And so really you're just correlating f prime with 4x cubed. That's what you're doing here. Okay, if f prime is 4x cubed, then what was f? And that was x to the fourth. So just kind of a creative way. I don't know if anybody think about that differently.
I just kind of looked at what was common between, the two latter parts, so D,
Mm-hmm.
and I just figured out that was negative cosine, or actually, well, I thought it was cosine, because I didn't pay attention, but, yeah, because that was the thing that the two got cosine in common, and I tried to pull that out. And then basically just figure out what D would be based on DB.
You guys want to do an FRQ?
I mean,
Let's do it.
We got 30 minutes.
Exactly. I'm not gonna deprive you guys of your learning. So I'm gonna put up, this was gonna be the warm up. I just didn't know in terms of time. So I think it's on the Canvas page for you guys at home, but I didn't know how much time we would have. I wanted to make sure we at least got through the lesson. So yeah, we'll try to spiral throughout the year, the AB content. Next Thursday is when we start like parametrics and then polars the following week. Before then, I would watch those two videos if you haven't, just refreshing like what they are. Just a heads up. So I'm gonna give you guys 13 minutes. It says sketch the solution curve, which means you're gonna have to open it up on Canvas, right? Yeah. The answer was yes. So you have to open it up on Canvas to sketch it. I'm gonna give you guys 13 minutes. On your mark, get set, go. See what we remember about AB calculus.
So far, I don't know.
I was talking to Braden about that because he texted me and asked me what my thoughts were about doing that. And I told him that,
I told
yeah, yes, you too. I told him to do it because he's smart.
Still a lot of content.
It's a lot of content.
On top of still doing it.
And on top of, he's not gonna be in class doing any sort of enrichment. He'll just be watching the lesson.
if anybody could do it, it's great.
That's
If there's a sub score, then yeah, I think he should. Yeah, it's fine. See what happens. Be interested.
The subscript is not that much for it.
There's still some, but not as much. That's what I told him. If there's no sub score, then he shouldn't do it. Two years a girl, or two. What is that? Can you see that? Huh? What? But it's mine, but it's not, I thought so too, it's on my own.
Very fast.
Oh, it is. I see it. It's like a little flea. Yeah, I can't pick him up without squashing him. Anyways. I asked Braden if he had a block 3 open, like get flex. He could just come in here and hit flex.
Oh, yeah.
But he hasn't even learned really integration. So he wouldn't be able to like
Even.
do the stuff we're doing. I had a girl 2 years ago. She did better on the BC score than the AB score. She got a 4 on AB and a 5 on BC.
Oh, here's my Vienna now.
By what?
Vienna. Yeah.
Interesting.
Yep.
Wonder if that's her middle name. She was a junior when she took this one. Well, that would be, I have this certain cost. What's the one? Oh, and then radiation. Cannon Barnett.
Yeah.
She just gave me $1,000
What?
indirectly.
Oh,
She goes to Notre Dame,
yeah.
and she emailed me last week and said she won a scholarship, and as part of the scholarship, she got to pick a teacher to award $1,000 to.
Oh.
So she gave me.
Yeah, she's on my show boy.
That was so cool. Umu Tyson, you know, for Umu? Part C is worth 6 points out of the 9. Huh?
So it's on D, so.
Yeah.
We'll get there when we get there.
You're stuck on D?
Yeah.
Still got about 5 minutes. which means I have to rewrite your signature. That's pretty much the signature. I'll spell your name right this time. I promise. You're welcome. One more minute. Get 9 out of 9. All right, time is up. So that was 12 minutes. You would get another 3 minutes on average. If that would help you.
That would.
Would that help or no? Okay. Was B still tripping you up?
Yeah,
Well,
those are the problems.
I started.
Okay. Okay. Well, let's look at the rubric and let's find out. Oh, here it is. Make sure when you guys sketch, if you do get a slope field question, they do say make sure you sketch to the boundary of the coordinate plane. So just make sure you go all the way to the end. You don't have to put arrows on the end or anything like that. Just you can end at the end. They're not extremely picky, so long as you're not blowing past any of those tick marks, like going straight through them when it's obviously wrong. There's, you know, not a perfect answer, but you get 1 point if you have the correct solution curve. The second one, so here's how I'm going to do this different than what's on the rubric. So anytime you guys are doing a tangent line approximation, first thing you want to find is the tangent line equation. And so they give you the point is 0, 1. You're going to use the derivative they give you to find the slope at that point. So here's the derivative. We're going to plug in 0, 1 into this equation right here. So the derivative at 0, 1 is, so cosine of 0, that's going to be 2 times 1, so 2. That means the tangent line is y minus 1 equals 2 times x minus 0. So x, that's your tangent line. Then you're trying to approximate the function at 0.2. So you're just plugging 0.2 in for x right here to get your answer. The way they do it on the rubric looks a little different, but the answer is 1.4. This is something, the reason I picked, there's always kind of a method to my madness of why I pick certain FRQs. And the reason I picked this one for a couple different reasons, not so much for part A. A big part is because of part B. We're going to learn something in a couple weeks called Euler's method. You guys ever seen Hidden Figures? She's at the board and she says it's ancient math, Euler's method or something like that. We're going to learn what that is. Basically, it's repeated tangent line approximations. It's like you're marching along a slope field using multiple different tangent line approximations. That's why I picked this one, to remind you guys of just in general what a tangent line approximation is, because we'll have to do several in one problem when we get to that. So that was a big reason. The third one, so Stephen, is the point you got, separation of variables.
Yeah, and I got the antiderivative, right?
Oh, so you got 3. So remember, when you are finding a particular solution, step 1, always separate the variables, separate the variables, separate the variables, separate the variables. Then integrate both sides. When you integrate 3 minus y, this is where that you could do u substitution, but this is kind of that case where it's just going to be natural log of 3 minus y. And then you're going to have the reciprocal of the y term out in front. So you get that negative out here. U substitution will do the trick. Then plug in your initial condition to find the c value at that point in time. Right after you integrate, I would plug in and find the c value. They got c to be natural log or negative natural log of 2. So that gets you to 4 points. No, that gets you to 5. If you could get to there. So then plug that in for c, and now we have to solve this equation. What I would do, so their steps are a little funky junky. I would divide everything by -1. This is where, I know in physics, doesn't he say like E it or something? That's in my classes I've said that before, but E it or whatever. But I like to just turn it into exponential notation. Where this is log form, I like to put it into exponent form. That's just how I think about it. So the base is E, so it'd be like E to this power, E to the negative sine of x plus natural log of 2 equals 3 minus y. And then just solve that for y. So you could add y over and subtract that. There it is. Gross looking. But fun.
It's a lot easier to.
Yeah.
Kind of forgot.
Well, that's why I'm here. To remind you. We'll kind of go back and. All right. So you guys at home, you are free to go. Have a good weekend. Stay out of trouble. Stay classy. Not sassy. Goodbye.
Have a good weekend.
You too.
After the AP test, you can finally plan on them. I don't think that people know, but
Oh, do people? I haven't played it in forever.
yeah,
People,
that's like your dad's.
is it? People going around.
I don't even play it.
I've never played it.
Really? When you say dead, just like a lot of people don't play, or it's like no one.
It's just not popular.
Yeah, it's not popular.
It
I'm sure
fell
people still
off.
play it. It's still fun.
It fell off slower than Fall Guys, though.
What's that?
All guys is like-
Fall Guys was not good.
All guns are
2
good.
week, 3 week try.
It'd be around longer if it weren't for.
What is? I never heard of that.
It's like like you're a little character and there's different mini games. You have to like not get knocked off or survive the mini game, and then you just keep getting smaller and smaller groups.
When was this popular?
Before Among Us.
Like right before.
Yeah, I'm on
And then Among Us stuff.
What's going on now? I played Fortnite the other day. Not embarrassed to say that.
I never played one time with my sister, but that always comes.
We got an Oculus Quest 2, so we've been doing a lot of Beat Saber. Yeah, it's been really fun. I'm through 2 parts of that.
I just finished the third one. I used the first one just to go to the.
Yeah.
I'm getting a lightsaber. I bought one.
I started playing Walking Dead Saints and Sinners. It's really hard. So this morning I got in here early and was watching YouTube videos on like tips and tricks of how to play it. I am gonna restart it.
Like it's on games, it's on an app called Wander, it's like Google Earth, but you can go there.
Mhm.
I helped a lot for quarantine, first I came to high school.
Like outside the doors.
Yeah, but I mean, like, you can go to all these cool places and just look around.
Yeah.
Have you tried the Plank experience?
Mm-mm.
That's from my aunt got one 2 Christmases ago. Her and her husband was super into that. got an Oculus, and it's just a little plane, you go up in the elevator, you have to walk out, and like no one can do it, just because, you know it's fake, it's all cartoon, but you can't get yourself in.
Well, in this Walking Dead game, when there's a zombie coming at you to bite you, it doesn't feel fake. It feels like you're getting chomped by a zombie.
Yeah, so,
My friend's brother punched his TV.
Oh,
It was
no.
like fighting people. It was like a brand new, like $1,000 TV.
Mm. Well, my son punched our wall, put a hole in the wall. Yeah.
I fall out with the dog, like with the green, I was like filling from the water, and there's a counter, so somebody weight on it, so I fell.
So it was my fault that he punched the wall, because you could set the boundary. So if you get close, it tells you. I just set it too close to the wall, so he didn't get warned in time. So it was my fault.
Oh, no.
I didn't get matter. Beat Saber is fun though.
It's really fun. You can download, songs online, so I like staying alive and learning, like,
You could get songs from online. I don't think it can come to the Quest.
yeah, there's a whole, like, I don't know, like now it's kind of weird, like I can't get the update, but I think if I took them off and put it back on. It was a process, there's like a little software to download, but you can get a ton of songs,
'Cause we paid for a few different packs of songs.
it's free, and it's pretty fun.
You should do VR chat.
What's that?
Oh my God.
no.
VR,
You like to run around, a bunch of random games.
I can't
There's tons
figure
of
out.
other people in it too.
Well, there's something called Rec Room, which I think that might be the handle that is.
It's similar to playing VR.
So I put it on just to hear what people were saying on there before, like, I let my son do it. He said, no, you have to meet everybody. It wasn't terrible, it just wasn't. I don't want just anyone to be able to say whatever they want.
Don't go to VR chat. Because
No,
especially when it's virtual.
It was so much fun.
I was playing Echo, it was Echo VR. So it's kind of like this, you fly around, you have the frisbee, like, but there was like 10-year-olds like cussing me out on there, like calling me trash and stuff. I was like, what? Echo VR.
I'm not good at throwing, so like during the tutorial, I just keep redoing.
But it's really fun.
Super hot, really fun. Have you played that one?
Super hot.
It's time when they move to you move. You know, these like red, they're like, they have circles that like shatter when you hit them, but they're coming at you. Like, it's like a first person like action thing.
Hmm.
It's really fun, this one. Like, you can like, you like shoot and like, they drop the gun, you grab it. It's really fun. My sister hates it, she was really scared, so. This is fun.
Have you played the like other Star Wars game?
The Johnson Good one? No, that's not.
I was wondering how that one was. All right, I gotta fill in this season. I was worried when we went to Red in Hamilton County that we wouldn't be able to come back to school. Happy that we did. I don't foresee us shutting down then. Yeah. The only way I can see it is if we didn't have enough teachers. So. Steve, I'm gonna try to spell your last name without looking at it. I don't think I stand a chance.
All right, let's do it.
Let me do it. Okay, here's what I got. Kozakiewiscz.
You were really close. Say it again.
Kozakiewiscz.
It's ICZ.
Just no S.
Yeah. It ends with Witz. The C is an E. If you say it, and the Z is an S.
Let me 8 of you. All right. Okay. My class, my AB is learning slope fields today. That's our lesson today.
When we do that, right after fall break.
Oh, probably. Then yeah, it's the next lesson after that.
Mission success. It's a real time.